Alright, so we're going to continue our discussion about slope and forms of linear equations by looking at two important forms that we can write linear equations in, which is slope-intercept and point-slope form. So these are like kind of the two main ways, because both of them, if the equation is written in these forms, it gives us important information about the equation or the line. So slope-intercept is probably the one, if you remember any from Algebra 1 and Algebra 2. We used it a lot in those. But slope-intercept is y equals mx plus b. So in this case, x and y are variables. They stay variables because every line, when you have a line drawn, it has an infinite number of x and y points on it. So this x and y represent the infinite number of different x, y points on my line that's going to fit my pattern for a specific line. The m and the b, though, those are going to be numbers. So the m is the slope of the line, okay, and the b is the y-intercept. So by y-intercept, remember, that is the point that the graph will cross the y-axis or the vertical axis at, is the y-intercept. So probably the most common form is this of a linear equation is this, y equals mx plus b. But we also have, which is point-slope form, which is also very useful. So point-slope form is written like this: y minus y1 equals m times x minus x1. Okay, so what do these stand for? Well, x and y are still just variables. Those are, representing the infinite number of points that are on my line. M is still slope. So m is still the slope of my line. And then the reason this is called point-slope form is because it identifies a point that the line goes through. So the point that the line goes through is x1, y1. So x1, y1, so x1 comma y1, that is the point, or a point, that the line goes through, I should say. So there's actually, every line, as I talked about, goes through an infinite number of points. So there's actually an infinite number of different point-slope forms you can write to represent the same line, because it doesn't matter which point you use, because as long as it's on the line, when you graph it, you'll get the same line. So m is the slope, which is non-changing, but x1, y1 is any point that's on the line. So let's see how to write equations here. So this says, write an equation in point-slope form of the line that passes through the points with the given slope. So I got 4, 6. So it's saying this line's passing through the point 4, 6 with a slope of -2. So point-slope form basically means I'm going to take this point in the slope, and just plug it into this equation up here. So y minus y1. So y1 is going to be 6. Okay, so I'm just going to write y minus 6. Okay, 4 is going to be my x point I passed through, or x1, and -2 is going to be my slope. So I'm going to write y minus 6 equals, so it's m on the outside of the parentheses, so that's -2. And then inside the parentheses is just going to be x minus 4, or x minus x1. And that's it. That's in point-slope form right now. Y minus 6 equals -2 times x minus 4. All right, over here, I got the point 0, -2 with a slope of 3. So once again, I'm just going to plug these into the right spots. So 0 is my x1, -2 is my y1. So I'm going to do y minus -2 equals m, or 3 in this case, times x minus 0. Okay, now this is technically in point-slope form. You could leave it like this, although this one can be simplified a little bit, because whenever you have minus and negative, it's usually a good idea just to change it into plus a positive. So instead of y minus -2, I can put y plus 2. And also, I've got x minus 0 here, which you can leave it like that if you want to, or if you want to x minus 0 is of course just x, so you can just write it as y plus 2 equals 3x, and that's also fine. So, all right. But that is point slope form. So if you're given a point and a slope, it's pretty straightforward. Okay. What about if we want to write an equation in slope-intercept form? So down here, I've got two problems. It says write an equation in slope-intercept form of the line that passes through this point with the given slope. So notice I'm given the same kind of information I'm given on these problems, but instead of my answer being in point slope form, I'm going to write it in slope-intercept form. But there's different ways to do this, but what I think is the easiest way is just to put an equation in point slope form first. So put it just like I did these problems here, and then convert it to slope-intercept form. So if I look at point slope form up here, I'm just going to plug these points into that. So I'm going to do y minus 2, because 2 is my y1, equals negative 1, because that's my slope, okay, times x minus 4. Okay, now you'll notice this is in point slope form, but to get it into slope-intercept form, all I got to do is make this equation look more like this one. So basically that means simplify it and kind of get the y part by itself, which is actually pretty easy to do, because all I got to do is I got this slope here, I'm going to distribute it. So I'm going to distribute this negative 1 across. So I got negative x plus 4, and on the left side I still have y minus 2. Okay, and then all I got to do to get this y by itself is to add 2 to both sides. So plus 2 over here, plus 2 over here, cancels out. I got y equals negative x plus 6. Okay, so y equals negative x plus 6, and I am done. I am now in slope-intercept form. So slope's negative 1, y-intercept is 6. Okay, same thing over here. I've got, going to just plug it into point slope form first. So y minus 10 equals negative 1/7, x minus negative 2. Okay, so now I'm going to distribute this negative 7 across, or negative 1/7 across. Okay, it won't be quite as convenient, obviously, because it's a fraction. Also, right away, I guess, too, I'm going to, instead of making this x minus negative 2, I'm going to think of it as just x plus 2 when I distribute, to make it easier on myself. So negative 1/7 x, and then negative 1/7 times positive 2 just becomes minus 2/7. When you multiply fractions, just think of 2 as 2 over 1. 2 times 1 is 2. 1 times 7 is 7. So minus 2/7. And then I still have y minus 10. Okay, so now to get the y by itself, to finish this off, I'm just going to add 10 to both sides. So that'll cancel. So I got y equals negative 1/7 x. Now you got 10 plus 2/7. So you can leave this in fraction form or decimal form. It doesn't really matter. But I would probably just leave it in terms of like an improper fraction, if anything. Or you can leave it in terms of a proper fraction, and it's an improper fraction. Negative 2/7 plus 10. You know, when you add this together, you have to get common denominators. So negative 2/7, 10 with a denominator of 7 is 70 over 7, because you have to multiply. So it's going to be negative 2 plus 7 is, or negative 2 plus 70 is negative 68, or sorry, positive 68, negative 2 plus, yeah, over 7. And so you can just leave it like that if you want to. Or you can put it as a decimal or an improper fraction. It's really up to you. But now it is in slope-intercept form. So negative 1/7 x plus 68/7.